Hi students, so welcome to the channel. So in this video we are going to make a quick revision of secants and tangents to a circle, so for IIIT exam. Alright, so this is also useful for our 10th class related syllabus. Okay, if you are new to this channel, so please subscribe the channel and watch the video till the end. Right, so if you like the video, please share with your friends. Right, so let us start the chapter. Okay, first of all, so we are going to discuss some of the points related to circles. So in a circle, so this is nothing but chord. So chord is nothing but the line segment joining any 2 points on the circle. Next, if the chord is passing through the center, then we call it as diameter. Right, if a line intersects a circle at 2 distinct points, then we call that particular line as secant. Next, if a line touches circle only at one point, then such a line is nothing but we call it as tangent, and where it touches the circle is nothing but we call it as point of contact. Right, so at the point of contact the radius will be perpendicular to the tangent of the given circle. Next, from an external point, if how many tangents we can draw? So we can draw 2 tangents and those distances will be equal. So PQ is equal to PR. And already we know, so at the point of contact tangent will make 90 degrees angle. So based on that we can, by using RHS congruency, so we can say that these two lengths are equal. Right, next, and one more thing, so if this angle is theta, then the angle formed here will be 2 times of OPQ. Right, next, and one more result that we can remember here is AQ is equal to half of the perimeter of triangle ABC. So if we have 2 tangents drawn and one more tangent is drawn such that it cuts the remaining 2 tangents, then one triangle is being formed here. So area, so perimeter of that triangle ABC is equal to 2 times of, so we can simply say it is equal to sum of these 2 tangents. Right, so using this concept, so we can solve some of the problems. Next, so special conditions. So in a quadrilateral, if ABCD is circumscribing a circle, that means circle is inside the quadrilateral, then we can simply say sum of opposite sides is equal to sum of opposite sides. Right, next, a cyclic parallelogram is nothing but we call it as rhombus, and a cyclic rhombus is nothing but we call it as a square. Right, next, moving on to, so the next part of this area is related to circles. So circumference of the circle is nothing but the length covered by, so the length of the boundary of the circle is nothing but we call it as circumference, and it is given by the formula 2 pi r, and area is nothing but the area covered by this particular circle, so it is nothing but pi r square. Right, next, so when we draw a chord, so a chord is drawn, then the given circle is divided into 2 parts, so major segment and minor segment. Right, the same way when radii is drawn, so we are going to have major sector and minor sector. Right, so if you want to find, so this particular APB, so this particular part is nothing but we call it as arc. So if you want to find the length of the arc, then it is given by theta by 360 into 2 pi r. So where theta is nothing but the angle made at the center to form this arc. Next, if you want to find the area of the sector, so area of the sector is nothing but given by, so this is nothing but my sector. So if I want to find the area of the sector, it is given by theta by 360 into pi r square. Next, if I want to find this particular part, so which is nothing but measured part, so this part if I want to find, then what I can do, area of sector. So if I want to find that part, area of sector minus simply area of that triangle. Right, so likewise we can solve each and every problem related to this. Right, next, moving on to the problems. So a tangent to a circle intersects it in how many points? So tangent intersects the circle only at 1 point. Next, we can draw how many tangents to a given circle? So how many tangents can we draw? So we can draw infinite number of tangents to a given circle. Right, so he did not mention from 1 point. So if he says from 1 point, so from 1 point how many tangents can you draw? So if this is a point and this is a circle, so from this point we can draw only 2 tangents. So only 2 tangents are possible. So when he gives one point, so from a point, so that point also should be external, right? So if the point is on the circle, then how many tangents we can draw? We can draw only one tangent, right? So if the point is inside the circle, we cannot draw any tangents. So what did he ask? We can draw dash tangents to a given circle. So to a given circle, how many tangents we can draw? We can draw infinite number of tangents, right? Next, moving on to one more question. So if the radii of two concentric circles are 6 centimeters and 10 centimeters respectively, then the length of the chord of larger circle which is tangent to the other is. So here we can simply, so there are two circles, so one inside the other. Now what he has given, so radius of this circle is 6 centimeters and the radius of bigger circle is 10 centimeters. Now this particular tangent to the smaller circle acts as chord to the bigger circle. Now from this what I can say, so this length is 10 centimeters and this radius is 6 centimeters. So already we know the tangent makes a right angle with the radius, right? Now this is 10, so this is hypotenuse and this is one of the sides. So clearly, so what I can say, so 10 square minus 6 square under square root gives me this value. So this shaded value, so this side length if I want, what I need to do, so from this what I can say, this is 100 minus 36, so which gives me 64. So square root of 64 is 8, then this part is 8, automatically this part is also 8. So from this what did he ask? Find the length of the chord. So length of the chord is 16 centimeters. Next, a line which intersects the given circle at two distinct points is. So he is talking about a line. So line means it is nothing but a secant, right? Next, a line which is perpendicular to the radius of the circle through the point of contact is a line which is perpendicular to the radius. So which is perpendicular to the radius and passing through and through the point of contact is nothing but we call it as tangent. The tangent is drawn at end of diameter r. So if there is a circle and to the circle, if there is a diameter, so at the end points of diameter, if two tangents are drawn, those tangents will be parallel to each other, right? Tangents drawn from exterior points are equal. So how many tangent lines can be drawn to a circle from a point outside the circle? Just now we have discussed, so we can draw only two tangents from an external point. If the point is on the circle, then only one tangent is possible. Next, moving on to one more question. The angle between tangent and radius drawn through the point of contact. So at the point of contact, they both will be perpendicular to each other, hence it is 90 degrees. Next, the longest chord in the circle. So the longest chord is nothing but the chord which passes through the center, and hence it is nothing but diameter. An angle in a semicircle. So angle in a semicircle is 90 degrees. So if we ask angle at the center of the semicircle, then it is 180 degrees. Angle at the center of semicircle is 180 degrees. Two circles having same radii are always congruent, right? Angles in the same segment of a circle are equal. Parallelogram circumscribing a circle. So parallelogram circumscribing a circle is nothing but a rhombus. Next, if ABCD is a quadrilateral and circle touches the sides at the points PQ, RS, then which of the following is true? So just now we have discussed, so sum of opposite sides will be equal. So AB plus CD is equal to BC plus DA. So you can just remember this. Next, moving on to one more question. So length of the tangent from point 13 centimeters away. So what is he asking? Length of tangent. So length of tangent, so that is nothing but this length of tangent. So 13 centimeters away from the center of the circle with radius 5, right? So if I want this length of tangent, so length of tangent is given by square root of d square minus r square. So simply you know doctor, right? So doctor means dr. So first d will be and later on r. So directly you can substitute the values. So distance is 13 square minus radius is 5 square. So clearly it is 12 centimeters. Next, length of the tangent drawn to a circle with radius r from a point which is distance. So already we have discussed d square minus r square. So answer is d square minus r square. So simply remember doctor. Okay. Next, moving on to one more question. A cyclic rhombus. So cyclic rhombus is a square. So just remember cyclic rhombus is a square, cyclic parallelogram is a rectangle. right? Next, a point P is 25 centimeters from the center of the circle. The radius of the circle is 7. Find the length of the tangent. So already you know doctor square. So doctor means 25 square minus 7 square. So 625 minus 49. So this gives me 576. So square root of 576 is 24. So answer is 24 centimeters. Next, if the radius of the circle is 5 centimeters, P is a point at a distance of 3 centimeters. Right? Then the number of tangents that can be drawn to the circle. So what is he asking? So the radius of the circle is 5 centimeters and there is a point at a distance of 3 centimeters. So 3 centimeters means that point P will be inside the circle, right? Because this total length is 5. So this length is 5, but point P is 3 centimeters away. That means it lies inside the circle. Then no tangents are possible. The number of parallel tangents to a circle with a given tangent. So if a tangent is already given, so if a tangent is already given, how many parallel tangents you can draw? Only one. So only one parallel tangent is possible when given tangent. So if a tangent is given, then only one possible. If for suppose, how many pairs of tangents are possible if he asked? So without giving any tangent, if he asks how many parallel tangents you can draw to a circle, that means you can draw infinite. So in such case you are going to get this infinite condition, right? Next, moving on to one more question. A circle can have dash parallel tangents at most. So how many parallel tangents we can draw to a circle? So this is nothing but my answer. So we can draw infinite number of tangents which are parallel to each other, right? Next, two concentric circles of radii A and B. The chord AB of larger touches the smaller circle at C. Then the length of AB is. Now what he has given? A is bigger circle and B is smaller circle. So this formula, so using this formula also we can find out the length of the chord. So in this situation, so what he has given, this is center. So these are two concentric circles and this radius is A and this radius is B. And what did he ask? Length of AB. So this is A and this is B. So already we know, so this is 90 degrees. So what about this length? So this length is given by root of A square minus B square. So if this is root A square minus B square, this is also root over A square minus B square. That means what we can say? 2 times of root A square minus B square. 2 times of root A square minus B square. Or simply you can remember this formula as 2 into square root of capital R square minus small r square. 2 into capital R square minus small r square. So this is nothing but that length of chord. So that length of chord is given by 2 times of capital R square minus small r square. So capital R is nothing but representing the bigger circle radius and small r is representing the smaller circle radius. So into 2 means, so this part is 1 and this is 2. So 2 times of root capital R square minus small r square. So remember this formula, right? Next, moving on to one more question. So if in the figure PT is the tangent drawn from P, so this is point P. Next, if the radius is 7 and distance is 25, length of tangent. So clearly 7, 24, 25 is the Pythagorean triplet, right? So 24 is the answer. So because directly you know the formula, right? So square root of d square minus r square. So d square is 25 square, 625 minus 49. Just now we did it. So the same answer. So if tangents PA and PB from point P to a circle with center O are inclined to each other at an angle 80 degrees. So there is a circle. So to this circle we have drawn two tangents from point P. So this is A, this is B. And already we know at the point of contact, so they will be perpendicular. Now what he has given? So they are inclined at an angle of 80 degrees. So if this is 80 degrees, then this will be, so already this is 90 and this is 90. So PA, so for suppose this is O center, PA OB is a quadrilateral. So sum of angles in a quadrilateral is 360 degrees. So already this is 180, sorry, this is 90 and 90 gives me 180. So remaining is 180 degrees, right? That means, so from this what I can say, if this is 80, then this center angle, so angle formed at this center is 100 degrees. Now what is he asking? POA. So if I join this, so he's asking POA. So POA is nothing but half of 100. So half of 100 is 50 degrees. Next, angle in a minor segment. So angle in a minor segment. So if you observe, in a triangle, sorry, in a circle, if a chord is drawn, so this is nothing but my major segment and this is my minor segment, right? So in major segment, if you observe, so if you consider with respect to this chord, if you consider any angle, so all these angles will be acute angles, whereas in minor segment all the angles will be obtuse. So what we can say, so in major segment angle is acute, in minor segment angle is obtuse. So simply remember this. So in major segment angle is acute, minor segment angle is obtuse. So what did he ask? Minor segment, so angle is obtuse. If AP and AQ are two tangents to a circle, so that angle POQ. So if we draw the figure, so what is given? So external point is A, so AP, AQ, and O is the center of the circle. Then what he has given? Angle POQ. So this is P, this is Q. Angle POQ is 110 degrees. If this is 110, obviously this is 70, right? Because 100 plus 70, 180. Now what is he asking? Angle PAQ. So PAQ. So it is 70 degrees. So answer is 70 degrees. So area of semicircle. So semicircle means half of circle only, no? So area of circle is pi r square by 2. So answer is pi r square by 2. Next, moving on to one more question. If the side of square is 4, then its area, so it is 4 square, which is nothing but 16 degrees. So cyclic quadrilateral. So what is meant by cyclic quadrilateral? So cyclic quadrilateral means nothing but all the vertices should lie on a circle. Now what he has asked, then angle A plus angle C. A and C are opposite angles in cyclic quadrilateral. Sum of opposite angles is supplementary, so which is nothing but 180 degrees. Now next, so what did he ask? Length of tangent. So clearly length of tangent means square root of d square minus r square. So what is the value? So distance is 8, so 8 square minus radius is 6 square, right? So from this what I am going to get? So 8 square is 64 minus 36. So 14 minus 6 is 8. So 14 minus 6 is 8. Next 5 minus 3 is 2. So root over 28. So this I can write as 4 into 7 now. So 4 into 7 means 2 root 7. So answer is 2 root 7. Next, if the length of, so if tangents PA and PB from a point P to a circle with center O inclined at an angle 110 degrees. So again, if I draw a circle with center O and PA and PB, so this is P, obviously these two point of contacts are PA and PB. Now what he has given? So they are inclined at an angle of 110 degrees. Then what is the value of POA? So angle POA is asking. So 110s, obviously what about this angle then? So 110, this is 110, right? Then what is this angle? 70. So 70 means, so this is exactly half, 35 and 35. So POA will be 35 degrees. Next, AP and AQ. So AP and AQ, that means A is external point. So AP and AQ are two tangents drawn to the circle with center O. Angle PAQ is 30 degrees. So this is PQ. So PAQ. So this angle is 30 degrees. So if this angle is 30 degrees, then this angle will be 150 degrees. Now what is he asking? Angle POQ. So POQ is 150 degrees. Next, the number of common tangents that can be drawn to two concentric circles. So if there are two concentric circles, so one inside the other, so is there any possibility to draw a common tangent? So there is no possibility. So answer is 0. So if two circles are neither intersecting nor touching, then we can draw how many common tangents? So totally 4 common tangents are possible. For suppose if they are touching externally, then we can draw only 3 tangents. So 3 common tangents. Next, if they are intersecting, then only 2 tangents are possible. If one lies inside the other, then only 1 tangent is possible, and later on the cases, so there is no tangent that is possible, right? If O is the center of the circle, so one circle is given with center O and PT, PS are two tangents. So PT and PS are two tangents drawn to the circle from external point. Which of the following is true? So simply what do we know? PT is equal to PS, right? So since the tangents drawn from external point are equal, so we can use the concept. Next, PA is equal to PA and PB are two tangents drawn to a circle from external point with the center O. So what he has given? PA and PB are two tangents. So if PA is equal to 5, PB is also equal to 5. So there is nothing much to think about it. So if there are more options, then we need to think of it, because here there is no angle given. So minimum requirement is, if angle is given, then we can think of the remaining things. But here he is talking about PB, so only PB possibility is 5 centimeters. Right. Next, which of the following has only one point in common to the circle? So what is that? Tangent. Angle in a major circle segment. Major circle segment means, so major segment. So what is meant by major segment? So major segment is formed when you consider two radii. So this is minor segment and this is major segment. So do remember, so do understand about the difference. So segment is formed, here major circle segment, no? So these are nothing but major sector and minor sector. So don't get confused. So here is talking about segment, right? So segment means, so this is minor segment and this is major segment, right? So if we talk about sector, so this is minor sector and this is major sector. So you need to understand the difference between major sector and minor sector, as well as major segment and minor segment, right? So here he is talking about major circle segment. So already previously we have discussed. So in major segment, so what is the angle? So angle is always acute, right? Next, two equal parallel chords of length 24 centimeters each lie on opposite sides of a center at a distance 10 centimeters from each other. Then the diameter of the circle is. So this is a question. So what he has given? So there is a circle. There are two parallel tangents. There are two parallel chords. So each one is 24 centimeters. Next, each lie on opposite sides of the center at a distance of 10 centimeters from each other. So from each other they are 10 centimeters. That means this length is 5 and this length is 5. Now this is nothing but my radius, right? Then what is he asking? The diameter of the circle. So from this clearly already we know. So the line drawn from center onto the chord will be perpendicular. So from this what I can say? If this is 24, then this part is 12. This is 12 and this is 5. Automatically this radius will be 13. By Pythagoras triplet, we can say radius is equal to 13. But what did he ask? So he is asking diameter. So be careful here. Diameter is 26. So answer is 26. So once again you see. So there is a circle. So in this circle we are having two parallel chords. So each chord is 24 centimeters, and from the center they are at equal distances, and what he has given, the distance between these two parallel chords is 10 centimeters. That means this particular distance is 10 centimeters. That means these parts are 5 centimeters. Next, this total length is 24, hence it is 12. So by using Pythagorean triplet, so what we can say, this is 12, this is 5, obviously this is 13. So radius is 13. So if radius is 13, diameter is 26. Next, what he has given, a circle touches all the four sides of a quadrilateral ABCD at the points PQRS respectively. AB plus CD is equal to 15 centimeters. So already we have discussed, right? So if a circle is circumscribing a so inside a quadrilateral, if a circle is there, then sum of opposite sides is equal to sum of opposite sides. So AB plus CD is equal to 15, then obviously BC plus DA is also equal to 15. Right. Next, moving to next problem. From a point T, the length of tangent to a circle is 24 centimeters. So length of tangent is given. The distance from the center is 25. So distance is given 25. Obviously radius. So is asking about radius. So already we know the formula, right? So what is that? L is equal to root over doctor square. So d square minus r square. So using this concept, so what we can say, L square is equal to d square minus r square. So from this, what do we need? R square. So r square is equal to d square minus L square. So d square minus L square. When I substitute the values, so 25 square minus 24 square. So this gives me, so 625 minus 576. So this gives me 549. So radius is 7 centimeters. So already we know 27, 24, 25 is a Pythagorean triplet. So based on that we can tell the answer. Right, next what he has given, a tangent PQ at a point P of a circle of radius 15 centimeters. So radius is given as 15 centimeters meets a line through center O at point Q, so that OQ is equal to 25 centimeters. Then what is the length of PQ? So length of PQ means, what is PQ here? Here PQ is a tangent, right? So he is asking you to find the tangent. So how to find the length of tangent? So L is equal to root over d square minus r square. So this is 25 square minus 15 square. So what is 25 square? So 25 square is 625 minus 225. So 625 minus 225 is 400. So which is nothing but 20. So answer is 20 centimeters. Next, O is the center of two concentric circles 3 and 5. He is asking length of chord. So already we have written the formula, no? So 2 times of capital R square minus small r square. So 2 times of, what is capital R? 5 square minus small r square is 3 square. So 5 square minus 3 square is 4 square. 4 square means 4. So 2 into 4 gives me 8 centimeters. So the answer is 8 centimeters. Next, a quadrilateral ABCD drawn to circumscribe a circle. If AB is equal to 4, CD is equal to 7, BC is equal to 3, then length of AD. So already we have discussed AB plus CD is equal to BC plus AD. That means AB plus CD. So that means 4 plus 7 is equal to 3 plus AD. So 4 plus 7, 11. 11 minus 8, sorry, 11 minus 3, 8. So answer is 8 centimeters. Next, AP and AQ are two tangents where PAQ is equal to 60 degrees. So such type of problems, so you need to make use of the figure. So sometimes, so he will be confusing with the letters. So A, P, Q. So APQ is the figure with the center O. So PAQ. So PAQ. So this is given as 60 degrees. So if this is 60 degrees, obviously this is 120 degrees. Now what is he asking? Just go through it. So POQ. So POQ is nothing but 120 degrees. For suppose if we ask POA, then it is 60 degrees again, right? So this diagram why we are drawing is so to get sure whether what the answer that we are getting is correct or not, right? Next, the length of tangent drawn from a point 17 centimeters. That means this is distance and radius 8. So what is the length of tangent then? So L is equal to square root of 17 square minus 8 square. So 17 square is 289. So 17 square is 289 minus 64. So 9 minus 4. So this gives me 225, which is nothing but 15. So from this, what is the answer? 15 centimeters. If a tangent PA touches a circle with center O at A, so what he has given? So there is a circle with center O and P is a external point and it touches the circle at a point A. So when the tangent is drawn from P to A, and what he has given, then what is the condition he is asking? So what is the condition that we can say? OAP. So angle OAP is equal to 90 degrees. So that is the only thing that we can say here, because no other condition is given, right? Next, moving on to one more question. So what he has given? So which of the following formula of minor segment? So how to find the minor segment? So minor segment is nothing but this measured part, right? So if you want this measured part, so what we need to do? So from this sector, we need to remove this triangle. So from this, what we can say? Area of sector minus area of triangle. So it is possible only in option A. So answer is option A, right? Next, the area of sector whose radius is 7 centimeters and angle is 72 degrees. What is area of sector formula? X by 360 into pi r square. So when I substitute the values, so 72 by 360 into pi r square. So pi I can write as 22 by 7 into radius is 7 into 7. So from this 177 gets cancelled. Next 36 table, so 36 tens are, this is 36 twos are, right? Next again, so any further cancellation, so 2, this is 5, so 22 sevens 154, so 154 divided by 5. So answer is option Bombay. The sum of major and minor arc of a circle is equal to dash. So what is the meaning of major arc? So major arc means, so minor arc means the arc which is having lesser length when compared to a semicircular arc, right? Next, major arc means, so it should be greater than the length of semicircular arc. So when you add these two, so what I am going to get? I am going to get the circumference of the circle, right? Next, moving on to one more question. So P and PB are two tangents drawn to the circle with center O from external point P. If angle APB is equal to 30, what is the value of angle AOB? So from point P, so we have drawn two tangents. So from this we have drawn two tangents, so with center O, so this is A and this is B. What he has given? APB. So APB is equal to 30 degrees. So if this is 30, clearly this is 150. So what is he asking? AOB. So AOB is 150 degrees. Angle made by minutes hand in a clock during a period of 20 minutes. So angle made by minutes hand in a clock during a period of 20 minutes. So for 1 minute, so for 1 minute, minutes hand rotates through 6 degrees. So for 1 minute, if it rotates through 6 degrees, for 20 minutes it rotates 20 into 6 degrees. 26 is 120 degrees. So it is nothing but 120 degrees. Next, perimeter of a semicircle. Perimeter of semicircle. So if you observe a semicircle, so it looks like this, right? So if you want to find the perimeter of this, then what is this arc length? So this is nothing but 2 pi r by 2, which is nothing but pi r, and this is nothing but 2r. So this is r and this is r. So if I want perimeter, so perimeter means sum of all these parts only, no? So pi r plus 2r. So pi r means, so 22 by 7 r plus 2r. So if I take LCM, so 22r plus 7 2 is 14r divided by 7. So 22 plus 14 is 36r by 7. So answer is 36r by 7. Right, next moving on to one more question. See here, so this angle is 60, so this angle is x degrees, right? So if this is 60 degrees, so this angle is how much? So this angle is 120 degrees, right? So if this is 120, then what about this? So this is 240. So if in this particular, at this particular center, if this angle is 240 degrees, then this x value will be half of it. So half of 240 is 120 degrees. So answer is 120 degrees. Next, if this is 70 degrees, then what I can say about this angle? It is double of this, because angle at the center will be double at the angle formed at the circumference, right? So this angle is 140 degrees. So if this is 140, then clearly this is 40 degrees. Hence x is equal to 40 degrees. And the next question, if two tangents inclined at an angle of 60 degrees, right? Two tangents are inclined at an angle of 60 degrees. So he is giving this angle is 60 degrees. Then what is he asking? And the radius of the circle are drawn to a circle of radius 3 centimeters. So this is 3 centimeters. Then obviously this angle is 30 degrees, and at the point of contact, so this makes 90 degrees angle. Now then the length of each tangent is, so when angle is given and radius is given, then we can directly find out the length of tangent. So length of tangent is this particular side, right? So what is this side with respect to this triangle? It is adjacent side with respect to this angle, right? Adjacent angle, and we know opposite. So adjacent and opposite, so that means we need to apply tan theta. So tan 30 degrees is equal to opposite by, we don't know the adjacent, so it is considering, we are considering it as L. So what is the value of tan 30? Tan 30 is nothing but 1 by root 3, which is equal to 3 by L. So on cross multiplication, L is equal to 3 root 3. So the answer is 3 root 3 centimeters. Next, moving on to one more question. In the figure, AB is the diameter. In the figure, AB is a diameter, AC is a chord of the circle such that angle BAC is equal to 30 degrees. If DC is a tangent, so this is tangent, then triangle BCD is asking what is triangle BCD. Now if you observe this, so this AB is a diameter, right? So if AB is diameter, that means this is a semicircle. So this forms a semicircle. So if this is semicircle, then simply what I can say, this angle is 90 degrees. If this angle is 90 degrees, then this angle is 60 degrees, right? So if this angle is 60 degrees, then what about this angle? So this angle will be 30 degrees and this angle is 120 degrees. So if this is 60, then this is 120 because this is a straight line. So this is 120 degrees, right? So if one angle is 120 degrees, then such, so if 120 degrees, then it is called as obtuse angled triangle. But here 120 plus 30, 150, then obviously this angle is also 30 degrees because sum of angles in a triangle should be 180 degrees. So 120 plus 60 gives me 180. So these two base angles are equal. So from this what I can say, it is an isosceles triangle. For suppose other than isosceles triangle, if he asked about obtuse angle triangle, then it is also an obtuse angled triangle, right? If the side of a regular hexagon is 2 centimeters, the side of regular hexagon is 2 centimeters, then its area is, so regular hexagon means, so it looks like this, right? So hexagon means it will have 6 sides. Now each side is 2 centimeters, so this is 2, 2, 2, 2 and 2. Now with the center, so with the center, if I join all these, now this particular value is 60 degrees and this is also 60 degrees, then obviously this angle is also 60 degrees, right? Then these side lengths also will be equal to 2. That means this is an equilateral triangle. Obviously all forms equilateral triangles. So how many equilateral triangles are formed? So totally 6 equilateral triangles are formed. So hence its area will be 6 times of root 3 by 4 a square. So which I can write as 6 into root 3 by 4 into, so what is side length? So 2 square, which is nothing but 4. So 4 gets cancelled. So answer is 6 root 3 centimeter square. Next, moving on to one more question. Now what he has given, so this is 90 degrees and this length is 12 and angle BAC is equal to 60 degrees. So where is angle BAC? BAC. So if this total angle is, so this total angle is 60 degrees. So if this total angle is 60 degrees, then this part angle is 30 degrees. So using this concept, what I can say, if this is 30 degrees, then I can find out opposite side now. So I can find opposite side since I know hypotenuse. So opposite side is nothing but sine 30 degrees. So sine, if you apply sine, then opposite is nothing but radius by hypotenuse is 12. So sine 30 is nothing but 1 by 2. So 1 by 2 is equal to r by 12. So in 2 table, so this goes 6 times, so r is equal to 6. So radius of this particular is 6 centimeters. Now in the options he is asking about OB. OB is nothing but 6. So answer is 6 centimeters. Next, from this figure, so from the adjacent figure, which of the following is false? Angle AOC is equal to 120 degrees. So what he has given, see here, so this is radius and this is also radius, right? So if this is the case, then what we can say here, so see in this triangle OBC, so in triangle OBC, so these two sides are equal, that means their opposite angles are equal. That means if this is 50 degrees, then this is also 50 degrees. So this angle is also 50. So 50 plus 50 is 100. Then this angle is 80 degrees. So if this is 80, then this is 100 degrees, right? Then what we can say, this is 40 and this is also 40, right? So we have found all the angles. Now what is it telling? Angle AOC is equal to 120. So what we got here? We got 100 now. So angle AOC is false. Angle OBC 50, this is correct. OCA 40, this is also correct. OAC is 40. So the wrong one is angle AOC. So it should be 100, but he has given 120 degrees, hence it is false. Next, moving on to one more question. From the adjacent figure, which of the following is false? So angle OTP. So OTP. So this is 90 degrees only, no? So this is correct. Next, angle OPT is equal to 60 degrees. OPT. So can you judge this 60 degrees? So we can't say. PT is equal to PS. PT is equal to PS. So this is correct because they are length of tangents drawn from external point. Angle TPS plus angle TOS. TPS plus TOS. So this angle and this angle sum will be 180 degrees. So option A, option C and option D, we can confirmly say that they are correct, but we can't judge this, hence option B is false. Next, coming to the next question. From the adjacent figure, which of the following is false? So PA is equal to PB. So this is correct. Next, OA is equal to OB. So since this is radius, it is also correct. OAP is equal to OBP is equal to 90. OAP is equal to OBP. So this is also correct. At the point of contact, it makes 60 degrees angle. Next, angle PO is equal to angle POB. Angle POA is equal to angle POB. So those are equal, but we can't say that it is 60 degrees. Hence option D is my false statement. Next, AB is a chord of circle. So there is a circle in which AB is a chord. Next, AOC is its diameter. So AOC is its diameter. So this is center and AOC is diameter, such that angle ACB. So he has considered angle ACB is equal to 50 degrees. Right? AT is a tangent. So AT is a tangent to circle at point A. So there is a tangent drawn at A. So this is some T. Then what is the angle BAT? So he is asking about BAT. So since this is a right angle, so clearly this is 90 degrees. Right? So if this is 90 degrees, then what is this angle? So this angle is how much? 90, 50, then this is 40. So if this is 40, then this angle is 50 degrees. Now what is he asking? Angle BAT. So angle BAT. So if I consider T this side, then this is 50 degrees. If I consider this side, then this is nothing but 130 degrees. Since all the angles are acute angles, so T is not this side, so T is considered this side. So this angle is 50 degrees. So angle BAT is equal to 50 degrees. Right. Next, moving on to one more question. So what he has given, PA is equal to 4 centimeters, BQ is equal to 3 centimeters, and AC is equal to 11. So this total length is 11. Then what is the value of BC? Now already we know. So to a circle, in this particular triangle, this point A, point B and point C acts as external points. So from there we have drawn external tangents. So that means 3. So if BQ is equal to 3, then BP is also equal to 3. If PA is equal to 4, then AR is also equal to 4. If RC, so if this is 4, so this total length is 11. That means RC is equal to 7. If CR is equal to 7, then CQ is also equal to 7. So what do I need? BC. So 7 plus 3, 10. So answer is 10 centimeters. If a chord of circle of radius 7 centimeters subtends a right angle at the center. So what he has given, if a chord of circle of radius 7 centimeters subtends a right angle at the center, then the area of minor segment is equal to. So if a chord of circle of radius, 7 centimeters subtends right angle at the center. So this angle is 90 degrees. Then what is he asking? The area of the minor segment. So minor segment is this part. So if I want to find that, what I need to do? So I need to consider area of this sector. So area of this sector minus area of this triangle. So area of sector formula is nothing but theta by 360 into pi r square minus half into base into height, half into base into height. Now when I substitute this value, so since theta is 90 degrees, so 90 by 60 into 22 by 7 into radius is already given 7, so 7 by 1 into 7 by 1 into 1 by 2 into, since this is a right angle triangle, so these two are nothing but the legs, so directly I can write as 7 into 7. Now this goes 4 times, next this 7 in 1 7, next this 4 in 22 11 times, and this 2 times, so 11 7s are 77, sorry here minus, right? So 11 7s are 77, so 77 by 2, so 77 by 2 means, so what I am going to get, so this is 77 by 2 minus, so 7 7s are 49 by 2, so 7 minus 9 we can't cancel it out, so 17 minus 9 is 8. Next here 6 minus 4 is 2, so 28 by 2, which gives me 14. So answer is 14 centimeter square. Next, moving on to one more question. So O is the center of two concentric circles. If AB is tangent, then what is AB? So AB is nothing but the chord, no? So already we have found the formula, right? So A is equal to 2 times of root over capital R square minus small r square. So directly substituting the values, so 2 times of capital R square is 13 square minus small r square is 5 square. So 13 and 5 they are Pythagorean triplet, right? So 13 square minus 5 square it gives me 12 square. So 2 into 12, which is nothing but 24 centimeters. So the answer is 24 centimeters, right? So thank you for watching the video and all the best for the exam, and stay connected with the channel for more videos, right? Thank you for watching.